Okay, sorry, we have to start video number 2. Okay, we were talking about UV catastrophe and what this means, like what happens here. So classical physics had told us that thermal radiation results from electrons just bouncing and oscillating and moving up and down near a surface. So I actually want to show you, I think, what this is. So let's follow me. Follow me, children. Okay, we're going to get into this at the end of this chapter, so I may as well show you this now. I want to use here. Okay, we're going to get into the Bohr's model, and you should have learned this whenever you were in chemistry. We'll all chuckle right now. Ha ha, yeah. In chemistry, there are several models of the atom. With these models of the atom, one of the most famous ones that you still use today, even though it's not accepted, even though it's not the correct, accurate model, teachers use it today because they think that it's really easy to show different amounts of energy levels. Now, in an atom, there are electrons that travel around the nucleus, so you already know that because electrons are constantly moving, just like the protons and neutrons in an atom in the nucleus are constantly moving. With electrons, they're constantly orbiting around that nucleus. So Bohr had a model, and Bohr's model is also called the solar system model or the planetary model. And the reason that they called it that was because he kind of thought that the nucleus was like the sun, and then the planets were like electrons, and the planets orbit around the sun just like electrons will orbit around the nucleus. So that's what Bohr's model was. And Bohr thought that electrons had to have certain amounts of energy levels. And the reason that they had these certain energy levels was because electrons that were really close to the nucleus didn't need as much energy because they want already to be there to the nucleus. Why would they want to be there? Let's think about this. Could it be because the nucleus has a positive charge and because the electrons have a negative charge? And according to law of charges, opposite charges attract? Yes, that would be why, so good job. So I don't need as much energy to get the electron toward the nucleus because it already wants to be attracted to that nucleus. If I want to take an electron away from the nucleus, I'm going to have to give that electron more energy because the electron wants to stay by something that's really, really positive because they're attracted to one another. So in this is just a model, and this would be like a Bohr's model as an example of a sodium ion. So I'm going to show you this, and just stick with me because I'm going to explain it to you, okay? Okay, my nucleus is in the middle here. So I'm seeing sodium. So my nucleus is just in the middle, and that's sodium, okay? I have 3 rings around sodium. And the reason that I have 3 rings around sodium is because sodium is in the 3rd row on the periodic table. And that just means it's in the 3rd energy level. So rows on your periodic table actually just mean energy levels. So I'm going to go over here to my periodic table that's in my room so I can show you this, okay? So that way we can all be on the same page. Which hopefully, again, we all should have learned this, but you know. Okay, so let's just focus here on what rows we are. At the very top of that periodic table, the very first element is hydrogen, and that's in row number 1, which means that hydrogen only has 1 energy level because it's in row number 1. Now, on the second row, I see underneath hydrogen is lithium. That's the 3rd element, and lithium is in row number 2, which means it has 2 energy levels. So if I wanted to draw lithium and its energy levels, I would do that. And the reason is because here's my nucleus somewhere in the middle. My first row would stand for this ring here, this first ring, and that's because I have to represent that I had 1 energy level. Now lithium is in the second row, which means that I'm going to have to draw another ring to represent that lithium has 2 energy levels. Now if we go back to our periodic table, sodium is right underneath lithium. It's in row 3, so how many energy levels would it have? 3. Okay, so it has 3. It has 3 energy levels because it's in the third row. Then potassium would be next. Potassium would have 4 rings around it, or 4 energy levels, because it's in the fourth row. Rb is rubidium. It has 5 energy levels because it's in the 5th row. So we're seeing this trend, okay? Now, I want to try to show you, I guess, how many electrons that we would have around each ring, because we're going to have to do this regardless within this chapter anyway, so we may as well just do this all now. Let's go back to my sodium, so then that way we can see this. Okay, here's my sodium atom. And I have on my first ring here, and remember, I have 3 rings. Why? Because sodium is in the third row. So since sodium's in the third row, I have to have 3 rings around it, because that means that electrons have to be traveling in 3 different energy levels, because sodium's in the third energy level. I want us to look only first at this first ring. And actually, let's just redraw this, okay? So that way we just do this step by step. Okay, here's my sodium atom. Actually, let me not put a circle around that, because then we're just going to get confused. Here's my sodium nucleus. It's going to be my nucleus for my sodium. Now, I have to account for all energy levels that sodium passed up. I know that sodium is in the third energy level, and I know that because I look on my periodic table and I see that sodium is in row 3. And since it's in row 3, that means it has 3 energy levels. So that means I'm going to draw 3 circles around it, because there are 3 energy levels, because it's in row 3. So that's what we're going to do. Here's my first energy level. Here's my second energy level. There's my third energy level. Okay, so I know that sodium, 3 energy levels. Now, how many electrons do I draw on each of these energy levels? Can I just draw as many random electrons as I want? No. I can't just draw however many random electrons I want. An element will hold a certain amount of electrons in each energy level. So at this point, we're going to have to go back to that periodic table, okay? The amount of electrons that you have on each energy level is going to depend on the number of elements that are in that row. So I want you to look at the very first row, and I want you to tell me how many elements are in that first row. So let's look. First row, I have hydrogen, and I also have helium. Those are the only elements that are in the very first row of the periodic table. So that means that the first energy level can only hold 2 electrons? That's right. So since there are only 2 elements in the first row, I can only draw 2 electrons in the very first energy level. So let's go back, and let's draw our first 2 electrons in our first energy level. Okay, so energy level, first one, closest to the nucleus, so I'm going to draw 2 electrons. I'm going to just symbolize that E with a little minus charge. So I have 2 electrons. Okay, and that's as many as I can fit on that first level, because there's only 2 elements. So now let's go back, because now I have to figure out how many elements can I draw on my second orbit. So let's go back to this periodic table. Okay, if I look at my periodic table, I know that the elements that are in the second row, is going to start with lithium. So in the second row, I have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So I have all of those elements. If I count how many elements those are, let's see, lithium would be 1, beryllium's 2, boron's 3, carbon's 4, nitrogen's 5, oxygen's 6, fluorine 7, neon is 8. Means I have 8 elements. So that means how many electrons can that second orbit hold? If you said 8, you got it correct. Because there are only 8 elements in that row, I can only hold 8 electrons in that orbit or on that energy level. So now let's go back. Okay, there's my sodium atom. So on my second ring, I'm going to draw in or write on 8 electrons. So here's 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter where I place them at as long as they're on that second ring. No, it does not matter at all. So you could have started placing them anywhere on that second ring. It does not matter at all, okay? Now I'm on my very last orbital. I'm on my very last ring. That's my last energy level. Okay, so I'm at sodium. Let's go back to the periodic table. Okay, sodium, third row, which means it's in the third energy level. If I look, sodium third energy level. Sorry, guys. Okay, sodium, third energy level. It's the very first element in that row. So, since it's the first element in that row, I'm just going to draw 1 electron. And that's because I can only fill in those 8 if I was all the way at the noble gases, but I'm not. I'm at the very first element in that row, so that means that sodium has to just be the 1 electron that's on the outermost energy level. Okay, so sodium, it's the first column, or it's the first place in that row, so then that means that it only has 1 electron. If we were to go to the next one, which would be magnesium. Okay, so we were at sodium, and that would be at 1. How many electrons would magnesium have? You should say 2. And then I go next to aluminum. How many electrons would aluminum have? I would say 3. How many electrons would silicon have? I would say 4. What about phosphorus? I'd say 5. Sulfur, I would say 6. Chlorine would be 7, and argon would be 8. So when you get at the noble gases, that's when you have that full outermost shell, okay? It's not until then that you're going to have a little bit less than that 8. So remember we said the number of electrons that we can hold within, number of electrons that we can hold on an energy level is just equivalent to the number of elements that are in that row, and that's it. And I know how many energy levels an atom has simply by looking at whatever row it is on the periodic table, okay? So when I say energy levels, that's what I mean. I mean that it's where the electrons are placed from the nucleus. So if my Na just represents the nucleus, I know that there are 3 energy levels. So this one would be my first row. This would be my second row. This would be my third row. Okay?